Welcome to today's broadcast with Gremlin and the World Innovation Lab. We're going to be talking a little bit about chaos engineering. So one of the interesting things though, we're working with the World Innovation Lab. We understand that innovation is extremely important. Innovation is how you win customers. It's the foundation of your business. It's what makes you successful. And we understand that in order to innovate, you need to be quick. You need to take your idea and build it out and get out there to market as fast as possible. And so we see things like Agile and DevOps, or you start moving to the cloud and microservices, which allows your developers to be faster and to push out code even faster and build out your product. Or you might be turning to containers or serverless and new technologies that allow them to be even faster to write that code. But we also understand that along with innovation, reliability is how you keep your customers. It's not just enough to be innovative. And so as we think about all these new technologies and these new processes that you're adopting to make your businesses successful, we realize that all of these increase the amount of complexity in your systems. We realize that as things become more complex and as you have more and more dependencies, traditional testing is not enough. We cannot just test the application code that our developers are writing. We now have dependencies on other software. We have configuration. We have cloud infrastructure. We also have the people and processes involved. All of these things contribute to a successful company, and we need to test them. Because if we don't, then failure will happen. We see it all the time. Massive failures from banks, from airlines, from companies in every sector, and they all lose customers because of it. You can think of it yourself right now, the last time you had a service that didn't meet your expectation, or a product that failed on you, and you thought, I'm not going to buy this again, or use this service again. So this is why we have chaos engineering. Chaos engineering is thoughtful, planned experiments that are designed to reveal the weaknesses in our systems. They help us test our people and our processes, along with our application and the infrastructure that we're running on. As we begin to test, it may sound scary. How do I break my systems or my applications and yet not affect my customers? But you really just need to start small. In the same way that you develop code and develop applications, start in development, move to staging, push into production, and gain that comfortability along the way. As you do, you'll start to mitigate risks and solve problems. We've seen this at dozens of companies, from companies like Dropbox that saw a 10x reduction in incidents, or Backcountry, which improved their monitoring, and now they can spot incidents in under 5 minutes. Or maybe you're actually starting your migration to the cloud like Under Armour did, and they were able to migrate to Kubernetes 4 times faster with less incidents. Or you might be like DPG Media. You run a game day and you do it on a regular basis and you find issues that you can fix. And so your customers are never affected. Gremlin is the chaos engineering platform. It was written by the experts and the engineers that started this practice, that created it at companies like Amazon and Netflix, and have made it available to companies like you. Why Gremlin? Aside from being the experts, we've made it simple. We have an easy to use interface. We've made it safe. So you no longer have to worry about causing damage to your systems because Gremlin will always default back to a safe space. We're also secure. And we're comprehensive. We're able to test every single layer of your application and your infrastructure. We're trusted by dozens of companies all over the world in all sorts of sectors, from retail to finance to tech and beyond. We'd love to have you join us on your journey. With that, now that you understand a little bit more about chaos engineering, we're going to turn it over to Sune and to Kolton to discuss a little bit more about Gremlin and chaos engineering.
はい、皆様こんにちは。私は株式会社ウィルの投資パートナーを務めております塩田と申します。まず簡単に自己紹介させていただきますと、ウィルという組織はですね、様々な産業の日本企業の皆様約30社より出社を受け、シリコンバレーと東京の2拠点でテクノロジー企業への投資とイノベーションの促進に取り組む企業でございます。私はシリコンバレーを拠点にですね、海外テクノロジー企業への投資を担当しております。今日はですね、日本でも非常に関心が高まっているカオスエンジニアリングの分野を先導する企業でありますグレムリンのですね、CEO コルトンさんからカオスエンジニアリング、それからグレムリンについてですね、日本企業の視点も踏まえて質問させていただければと思います。というわけで、ここから英語にスイッチしてですね、進めていければと思います。Okay, that was a brief introduction in Japanese. And Kolton, it's so great to do this webinar today. Let me just start by asking a kind of simple question, which is why now? The chaos engineering is gaining momentum, and a lot of people are interested in it, and many people started doing it. And I think that means people realize that it's necessary and it's important. So from your perspective, why is that happening, especially at this moment in time?
Yeah, no, thanks for the opportunity, and great to be able to do this together. My first exposure to this practice of chaos engineering came almost 10 years ago, a little bit over 10 years ago now, when I worked at Amazon. And at the time, as we were embracing microservice distributed system architectures, this became the way in which we were able to understand and find those unknown unknowns and really train and prepare our software. So I think why now is a question of where the market and the industry are at. 10, 15, 20 years ago, if you're running a monolith and your system is fairly straightforward, you may not have needed these more aggressive techniques to go understand and harden your system. But as everyone has moved to the cloud, as everyone is moving to distributed microservice architectures, as everyone is embracing this modality to be able to get more done and to be able to move quicker, it comes at a cost. And one of those trade-offs with complexity is that now someone else's software can cause your software to fail. So I think that's one trend that I've seen over the last decade. I would say over the course of this year, what we've seen is COVID has highlighted that our society is highly reliant on the technologies that we have built. And it's not more than an inconvenience, it's a critical issue when these software systems fail. And when we all have to deal in this new environment, the stakes have been raised. People expect more, that they're going to be a little bit less tolerant if things fail. Some of our customers have seen just a massive increase in the traffic that they've had over the last 3 to 6 months. And some of them, they've weathered it very well because they worked hard and they prepared in advance. Some did not prepare as well and really had to scramble and had to adjust to these new patterns and this new world. And so that's one of the reasons I feel like chaos engineering is a must-have, is that by doing the preparation in advance, things will go according to plan and smoothly when unforeseen circumstances occur, or when failure, which at scale is not an if, but a when, then you'll be able to weather those well.
Got it. Makes sense. Great. So you mentioned, the two things kind of came to my mind. One is the state of the market that you mentioned, and the other thing is, getting ready for unforeseen circumstances. From like a Japanese person's perspective in the Japan market, the relevant themes for those are, I would say, kind of transition to cloud for the state of the market. And for the latter, unforeseen, events, I think its typical thing is earthquakes and natural disasters. So can you speak to those points a little bit? When people think about transition to cloud, migration to cloud, which is happening in Japan, probably slower than in the US, but it's surely happening. So in that transition, how chaos engineering could be helpful? And then I'll follow up on the earthquake or disaster recovery question.
Yeah, so moving to the cloud, has its pros and its cons. And the ability to have someone else manage your infrastructure can be a huge convenience. It also means that you don't have direct control of your hardware. You can't send someone to a data center. You can't, physically go solve a problem if you have it. You have to rely on someone else. And I think it's really that reliance on someone else where it's our due diligence to go ensure that they're doing what they should and that we understand how the system behaves. An example of that is if you run a software application in a data center, maybe your hosts don't go down very often. Maybe I knew system administrators in the 90s and the early 2000s that bragged about their system uptime and the fact that their hosts never rebooted. That's almost an anti-pattern in the cloud where we're recycling our hardware on a regular basis. But what that means is if you had built your software such that you had a cache on that disk, or you relied on, information that was stored on that host that was lost on a reboot, in this new world where that may happen to you, you may not be told, they may replace it and give you another one. What will your application do? And that was really, I think, the genesis for a lot of the Chaos Monkey randomly rebooting hosts is, number one, this is going to happen. Number two, if you have things that you're unaware of that you rely on, when this happens, there will be an outage or there will be pain. And three, by purposely having our teams go out and spend time testing that, we're not going to be surprised. We're not going to have a bad customer experience. And I think that's really one of the keys is there's this debate of will failure occur? And I'd love to have that, but the truth is at scale, failure will occur and in many varied ways. And so when failure occurs, have you built a system that heals and that recovers quickly and that keeps your customers having a good experience, even if not everything is working correctly? Or does it hard fail and just the pages don't load and the service doesn't work? And I think that's a degree of maturity you see in cloud companies, where the more mature you get, the less obvious it is if they're having an outage. It may just appear as a service degradation instead of an entire outage.
Got it. Yeah, so I think it's a good point that the failure can come in different forms, but the most dramatic one could be the large earthquake that hit Japan, for example, back in 2011, and thereafter there are several earthquakes and natural disasters.
So an interesting story on that one. I was on call at Amazon when that earthquake hit. I remember
in 2011.
In 2011, because I logged in because I got paged. It was a SEV1. It was 20 to 30% traffic drop in JP. We got on the call, we start investigating, we start checking load balancers, we start checking that we can get traffic, we're checking for service level errors. The system looks fine, everything's healthy. There's just 20%, 25% less traffic. And about 15, 20 minutes into that call, somebody said, hey, there was just a big earthquake, and we think that might be the mitigating factor here. And obviously, if an earthquake just occurred, people have more important things to worry about at that moment than shopping on Amazon. And so it's understandable that the traffic would drop. But it's also an interesting story that we were prepared to go and address and handle that in whatever way we could, because we had thought of these scenarios and we had and prepared for them. In this case, there was nothing for us to do. And that's the best outage in many ways, because the system has handled the failure correctly. Sorry, that just came to mind.
Yeah, I mean that's a great story. You guys were prepared. But in the event, so natural disaster hit. I mean, all sorts of things could happen. Your cloud system may go down, or your data center may stop functioning well, or whatever thing. So what's the actual kind of step to be prepared for those different scenarios, especially when it comes to those unexpected situations?
Yeah, the first thing that comes to mind here is being, in AWS or in cloud terms, zone or region redundant, and kind of in the old world data center redundant. And this to me is an important one, because we've been practicing disaster recovery, some places better than others. And I assume Japan is the best at earthquake preparedness and drills and preparation. And I would draw that corollary here. If there were an earthquake and one of our data centers or one of the regions that we operate in was unavailable, but our customers still relied on our service, what would we do? Well, that's where you typically run multiple data centers, multiple regions. You're running multiple versions of your service active at the same time. Now, the key to that, because you may need to shift traffic, there may be DNS involved, there may be data locality, you may be storing some customer data here or some there, there may be some delay in how that's transferred. On the surface, saying, yeah, run 2 data centers, and if something happens to one, just fall to the other one, sounds simple. But there's a seductiveness to that simple. This is where I like Adrian Cockcroft's term, availability theater. Sometimes we say we have a plan and we feel like we're safe if this happens, but if we haven't prepared, if we haven't practiced, if we haven't gone and done it for real ourselves, then truthfully, we're not prepared. And I've seen this occur as well. So an earthquake occurs and we have a plan that was very well written and we all talked about it, but no one ever went and practiced it. No one ever ran a drill on it. And we go to shift traffic from one data center to another and we run into an error with a security group, or we find a load balancer that doesn't work right, or we find that a service doesn't operate the same in the other region, or maybe that service can't handle twice as much traffic when it falls over on it. These are the practical concerns that arise, that it's our due diligence, it's our duty to go and to make sure that we've gone through this process in the real world. And that's why, you know, my advice and the best practice here is to run these evacuation drills, these service evacuation or region evacuation drills on a regular basis, weekly, monthly, quarterly, but some regular cadence that proves that will actually protect you.
Got it. Great. Yeah, makes sense. I mean, yeah, to your point, we're very used to doing an evacuation drill when it comes to earthquakes. But when it comes to systems, I think in Japan, at least, the historical approach has been, okay, let's hope nothing bad happens and things are working, so let's not touch it. And I think there's a kind of truth about, you know, people don't want the system to go down. And, you know, no one wants that to go down. But at the same time, there's this kind of social kind of attitude toward failing the system and be very conscious and somewhat afraid about that. So that even prevents more people from sort of touching the systems in a deep way. So I think, you know, I understood the evacuation and, you know, being ready and doing due diligence, but help us understand how people feel more comfortable with taking those steps. How do organizations overcome this fear of potentially doing the evacuation drills? They may actually break things.
So I understand this fear well. It was my job to prevent outages at Amazon and Netflix. I never wanted to cause an outage while trying to prevent one. I never wanted to go into the room of my peers, where I'm typically on the other side of the table asking why things went wrong, and explain that in trying to make things better, we made things worse. And so we thought a lot about how do we get the value that we need without putting ourselves at unnecessary risk. And that's where, again, there's subtlety. If people think about if it's either on or off, the data center's on or the data center's off, that's a big switch. There's a lot of things that can go wrong there. That isn't how I would recommend running that experiment. If we want to prepare for region evacuation, we should start very small. First, we should start in a development or a staging environment where failure may be an inconvenience to our fellow developers, but it won't have an impact on our customers or on the business. The second one is we always want to run the smallest experiment that will teach us something. If we can test our zone or region evacuation using 3 hosts instead of 300 hosts and find and fix the same bugs, then that's efficient engineering. We're able to uncover and de-risk things without taking near as much risk. Now, in reality, that won't be sufficient. Like the development or the staging environment, we're starting at the 3 hosts. We may find 50% of the things that could go wrong. We may find 75%, but we'll never find 100%. And the truth is, our production environment doesn't look like development or staging, and there are the unintended consequences. There are the dependencies we take. Some of them might be internal dependencies, fellows, peer teams of ours. Some of those might be external dependencies that we have no control over. And so that's where there's this concept of the blast radius. When you're running an experiment, what's going to fail? Start with the smallest thing, test that. Once you have that working well, the risk of going to the next step up is much lower because you've already eliminated the risk from this section. So you add in incrementally a little bit of risk, but you're testing more and more of the system. And by taking that staged approach and slowly building it out, you can take away a majority of the risk while still getting the value. The other piece that's critical in this world is the equivalent of like the and-on chord or like the halt button. Like if things go wrong and we know it's not behaving as expected, we're not going to just blindly follow through on that experiment and knowingly cause pain or harm to our customers. We're going to stop that experiment immediately. We're going to clean it up and we're going to go understand what went wrong. Now, the crucial thing there is, if we're running these experiments, we could catch it in seconds. We can see that things start to go off the rails or not as we expect, and we can quickly halt that and clean it up. And there's a bit of a pain tolerance at play where if you have, if a customer hits a page and they've got to reload it once or a retry happens, it's probably as if the failure never occurred and they can continue on. But if the failure prolongs and it's clearly noticeable and multiple attempts fail, that's where you're going to damage customer trust in your brand. So those safety features are a key aspect.
Got it. Yeah, makes sense. Makes a lot of sense. And so let's say, if you start embracing chaos engineering, understood the benefit of it, but how do people actually make sense of the benefit? People want to avoid downtime and start doing the diligence and getting ready, doing chaos engineering, but it requires efforts. And how do people kind of make sense of that efforts versus the actual benefit that they gain?
Yeah, it's an interesting one because as helping evangelize a new practice, on one hand, there are so many things we can do with this technique. Load balancers, routers, data centers, IoT devices, just a whole variety of breadth and depth, types of failure scenarios and things that can go wrong. And then it becomes quickly, what are the most important ones to me and how can I get them done as efficiently as possible? And so as we've worked with many, many customers, we've begun to see the patterns that matter most to different industries or to different groups. At a high level, I kind of break it into three categories. There's our alerting and monitoring. We have to make sure that when we get alerted, it's actionable. There's signal versus noise. And if we get too much noise, we'll start ignoring things. And we need to make sure it's timely. If we don't get paged for a failure until 10 minutes after it started, that was 10 minutes of wasted time. As soon as we know it's a problem, we need to be involved and we need to test those people and processes. What is our incident management process? Who's in charge? Do we join a phone bridge? Do we join a Zoom call? Do we join a Slack channel? How do we coordinate during it? Who's in charge? What's the process we follow? Many teams in our industry, again, I'd actually draw the analogy back to the earthquake. You grow up, you do earthquake training, you do fire drill training. It's part of society. It is taught to you because it's known to be important. Our engineers that are put on call often are given no training. They're left to figure it out on their own and trusted that they're intelligent people, but it's just not a pattern for success. By giving people an opportunity to practice during the day and to test these things before things go wrong, we're going to shrink the amount of time of the actual outage, but we're also going to make our team feel more comfortable and confident in handling those issues. You talked about kind of the psychological safety of causing failure, and people don't want to cause failure and people don't want to be responsible for causing failure. But there's almost the flip side to that if you've never experienced failure, you're not going to handle it well. And by going and preparing for it, then when it occurs, we can do the right thing It's just like firefighters have to train by running into burning buildings. Like at some point, you have to do the hard things if you really want to do the best job possible. So monitoring and alerting are important. Testing the people and the processes are important. Understanding the resource constraints of your system. So what happens if a disk fills up? What happens if I'm CPU bound or thread bound or IO bound? Those are all very helpful in knowing the edges of your system and making sure if one of those starts to behave incorrectly, you detect it or you mitigate it. You know, where possible, you just fix the issue on the spot. The last one to me is really about redundancy. But when we talk about reliability, everything is at some level about redundancy. It's all about, can we find another way to get the answer or serve the customer if possible? We talked a bit about zone and region redundancy. I think that falls into the host level as well. Can we lose a host without anyone noticing? Can we lose a zone without anyone noticing? Could we lose a region without anyone noticing? An increasing level of difficulty. But then when it comes to these distributed systems, these architectures where we may have 10, 20, or 100 different services we rely on to collect data or to process customer requests, those are also things that need to either be redundant or we need to understand if they're critical or if they could go away. And so on that side, number one, the ability of, first of all, there's often like a cache and then a service and then a database. And so there's multiple layers of things that can go wrong. And if you own that service, maybe you want to test that you can lose your cache and things fall to the service, or you can lose one of your databases and have redundancy and fall over to another. That's your best practice. But then the person that calls you needs to make sure either A, that service is going to work well, or if it fails, what do I do? And that question, while it seems simple, is actually one that most teams don't ask themselves. There's a business question, not just a technical question. Hey, I'm loading my web page and I'm showing someone an item they want to buy. And I need to show them all the things that I might recommend they buy as well. But that service failed. So should we show them a preloaded set of things that aren't really personalized, but show content there? Should we remove that content altogether? Should we try to find that content from another place? Should we cache it and serve it up in the case of failure? And that to me is where we really get into the interesting engineering of what is the customer experience and what is the right behavior of our system.
Great. Yeah, and obviously for companies across the world, including in Japan, more businesses are relying on the online side of the business, whether it's retailer or media or whatever. And do you have any kind of thoughts, or at least based on your interaction with the customers, what's the kind of financial impact or damage that this system failure could cause? I think that's a big motivation too. So curious what kind of statistics or the magnitude that your customers talk about.
Yeah, I mean, we did a lot of work specifically at Amazon to measure this cost. And when you can't sell something, but you have kind of predicted traffic levels, what customers tend to buy. And when you see a big deviation from that, that's your delta. That's the amount of money you're losing. And that can be quantified. And early days, that was tens of thousands of dollars a minute, but now it's hundreds of thousands to millions of dollars a minute. And that cost is an important trade-off. If your company does $1,000 of sales in an hour versus if your company does $1 million of sales in an hour, in the former, maybe you could be down for 30 minutes and recover as a business. In the latter, can you lose $500,000 in sales? Probably not. And so what's the right level of investment to prevent that? If you're at the earlier stage, the investment might be, less. You might do something quarterly or monthly. You might spend a little bit of time. But if you're at that scale, the large enterprise scale, then it's almost an easy answer. If you could lose $1 million in an hour, it's well worth spending $1 million on a team to prepare for and prevent that hour from being lost. Mm-hmm. Excuse me. So I think there is the revenue side. How much money could we lose? There's an impact to brand and customer trust. The brands that are always work, that are always reliable, you know, there's an intrinsic psychological safety there where people really value that, and they're going to trust that. They're going to rely on it. And if that fails, and if customers lose trust, they're going to go to a competitor. You know, the benefit of online and the detriment of online is if your service fails and I can open another browser tab and go to somewhere else and solve my problem immediately, then my tolerance for your failure is much lower. And then I think the third category is the engineering time that goes into this. Engineers are expensive. And when a big failure happens, there's often a conference bridge with 20, 30, 40 engineers on it for a couple of hours. Right there, you're spending a lot of your money on that. But that's a bit of the tip of the iceberg. You then have to go and diagnose what happened, dive into the logs, collect the metrics, write a postmortem and an explanation of what happened and what you learned, share that with the group, take the things that you want to improve and go fix them. And so that whole process actually eats a fair amount of engineering time. One objection I hear to this approach is, you know, we don't have time for this. We're trying to get this feature out the door. We need to make our product better. We can't worry about reliability. But the truth is, you're going to pay the same, you're actually going to pay more time if you don't prepare up front. You could spend an hour a week, or you can spend 50 to 100, you know, engineering hours in one afternoon or in one weekend when things go wrong. And it becomes a cost of, would you like to amortize it and would you like to plan for it? Or would you like to be surprised and be behind and delayed because you had to eat that cost that you didn't account for?
Great. Yeah, makes sense. And I especially, you know, the financial aspects, you know, makes kind of total sense. More businesses becoming online, it's becoming more important, and the downtime will have big financial impacts. But like from a Japanese person's perspective, you know, the point number 2 you mentioned about, you know, goodwill, or, you know, helping customers do what they want to do, right? And by not being available or having system issues, letting customers down, I think that's a big concern that all the companies in Japan across the industries, you know, whether it's again retailer or financial services or anything, I think that's a concern people have had. But my observation is that there's no like approach that they could kind of turn to actually avoid that situation. So like I'm very excited about the potential for this approach to help people avoid letting their customers down.
Bad engineering is impolite to your customers because you inconvenience them.
Great. Yeah, good point. Great. Maybe final question from me. So this all sounds great. You know, interested in chaos engineering. Where can I go and what can I do to start taking steps toward that?
Yeah, you know, I think before I answer that, one other thing I hear a lot is, hey, you know, we don't think we're ready. You know, this sounds like it's more advanced than we are. We might not be there yet, or, you know, we already have enough chaos in our lives. We don't need any more chaos. And to the folks that feel that way, I want them to know, number one, like there's easier and harder things to do, and the easier things are going to help you get better and level up. And so the time to start is now. And in terms of, you know, we have enough chaos in our environment. There's already enough failure. Truthfully, chaos engineering is about removing the chaos. It's about finding and fixing things so we have boring systems. It's not causing chaos for the sake of chaos. It's really removing chaos. And so if you live in that world, we are here for you. This is what you need. Simplify your problem, put out your fires, stop playing whack-a-mole, and be able to sleep peacefully at night. That's really why we founded Gremlin. There's a great chaos engineering community. You can get to it via gremlin.com/Slack, and that'll allow you to it's a public chaos engineering community that we help facilitate, but isn't Gremlin specific. There's a lot of places to ask questions, to get advice. We've built a community section on our website that is filled with tutorials, with guides that are based on specific technologies or specific frameworks that you might be using. And of course, this is what my team does. We were practitioners. We've been on call for the last 10 years. We've been really focused on how do we help customers understand their systems, understand where to begin, and effectively invest their time to mitigate this risk. So of course, we'd be more than happy to speak with folks and to be able to help them along the way.
Excellent. Great. Thank you for that. And thanks for sharing your thoughts about chaos engineering. Again, I feel very excited about the potential for chaos engineering and you guys, Gremlin, for the Japan market, especially when people feel very concerned about letting their customers down. So I think it's a great fit with the country and hoping that many people embrace chaos engineering so that they can help customers.
Well, thank you very much as well. I appreciate the opportunity. And as an engineer, I'm always happy to help educate and teach people what I've learned and help them along their path.
Great. Thank you, Kolton.
Thank you.
Thanks for the fantastic discussion, Sune and Kolton. As mentioned, there are plenty more resources online. If you'd like to learn more about chaos engineering, you can visit gremlin.com/community. That has a lot of resources and gives you access to that chaos engineering community Slack that Kolton had mentioned. Or if you'd like some resources in Japanese, you can visit our partner's class method at the URL listed on this slide. Thanks for joining us.